Okay. All right. I'm going to mute myself then, and we'll just wait for a few minutes. Okay. Sounds good. I sent a link on the announcement board to the answer key to the review. So if you want to pull that up, that might be something you can look at. And then you can see the stuff that you missed at the end of class on Monday. Okay. I'm going to share my screen with you so you can see what to do. Should get really weird for a second. Okay. So to get to the answer key that I sent out, go to Blackboard, and under announcements, it's this OneDrive Live link. You just click on the link and it will throw you over to this screen. And on here, I think when you first jump in, it looks like something like this. You just come down and click on the review from class. And that's the thing that I was writing on from class. Now, hold on. Stop sharing. There we go. Anyways, hopefully that helped. Sounds good. Later. Or see you in a few. Well, I don't know where anyone else is, but since you're here, if you got anything you want to go through, I mean, I can go through the rest of the review, or I can pull up some practice questions, and you can, I mean, if it's just the two of us, you can unmute it. You can actually talk. You don't have to type out everything. Yeah. Let me pull that up.
I don't know if my microphone's working.
Yes.
There we go. I can always tell it does something freaky. Okay. I'm gonna take a picture of this and make it bigger, and we can focus in on that. Okay. So in number 3, we're told that there's a department store with 3 floors and an elevator. But in the setup, they actually tell us it's a uniform distribution going from 0 to 4 minutes. So you could hit the button and it could immediately open up, or you could hit the button and it could take 4 minutes for the thing to get to wherever you're standing. So in a uniform distribution, we represent that using a rectangle. And I'm going to label the lowest value at the beginning here, which in this case is 0, and the highest value at the other end. It's not always going to be that way. Like, it's not always going to be 0 and then some other number. Just depends on the problem that you're being given. And then the height of the rectangle is 1 divided by the range. So whatever the high minus low is, whatever that number happens to be, that's going to be what your height of the rectangle will be. And then if I want to figure out the mean of this, it's the lowest plus the highest divided by 2. So the average of the two numbers. So on average, I would expect someone to wait 2 minutes. And the standard deviation is, the formula is b minus a squared over 12, gives the variance, and then we just take the square root of that. So just plug that in a formula and you get 1.154. And you should have the formula written down. You do get to use that on the test. So if you don't have that written down somewhere, then I would just add that to your notes. And then part B, once we have this distribution drawn, then I can come over here and it says find the probability of someone waiting less than 1.5 minutes. So I want to know what percent of this rectangle is between 0 and 1.5. So I'm trying to find that area. So the length here is 1.5. The height happens to be 1/4. And if I type that in a calculator, I get 0.375, which in real world terms means the likelihood of someone waiting less than 1.5 minutes, about 37–38% of the time someone would wait less than 1.5 minutes for this elevator, given all these other parameters that they gave us. Okay. Anything else about that one? Okay, good. Anything else you want to look at? All right, number 8, not a problem. I'm going to do the screen share thing. It's always creepy to do that. Number 8, right here, A, B, C, and D. Okay, and let me make it bigger. Well, that didn't go so good. Let me try that again. Copy. Copy. Man, why is this being picky? All right, hold on. Let me try this one more time. Should just let me copy and paste it.
Pause for action. Pause for action. You're supposed to be working on pause for action, but it would be awesome if you could get 3A or 3B now. I think I have to do it with you. I think it has to be something on the house. Make sure the house.
All right, there it is. Okay. All right, so the setup is we have a library campus. It's got an elevator, and it's one of those elevators that says you have a limit of 16 people. You do not to go over a total weight limit of 2,500 pounds. Okay, so the question is, if 16 people happen to get on the elevator, are we all going to die? It's not really the question, but that's kind of a fun way to think about it. All right, so they tell us that we're assuming that the average weight of everyone happens to be 150 pounds, which I know is not realistic at all, with a standard deviation of 27. And the distribution of weights is approximately normal. So if we have a random sample of 16 people, what would be, okay, so because we're dealing with a sample, then we're going to do sample distribution rules. So sample means is the same as the population mean. So because they tell me that on average each person is about 150, then if I collect 16 random people, add them up, divide by 16, I'd still get about 150. So the mean of the sample, so mean of X bar happens to be 150. The standard deviation of the sample is going to change from the population. So since the population is 27, then I want to take the 27 and divide it by the square root of the sample size. So if I type that in a calculator, I should get 6.75. So that's part B. It's a standard deviation of that. Part C is saying, what is the average weight for 16 people that will exceed 2,500 pounds? Well, even though the assumption is that an expected weight is 150, in order for it to be larger than 2,500, that means each person on average has to be, well, 2,500 divided by 16, so it has to be about 156.25. Okay, so I just took the total weight divided by 16, and then there's our magic, what we call the fat person number is 156.25. And then we finally get to use our calculator. So part D is asking, what's the probability that a random sample of 16 will exceed the weight limit? Well, that's the same as saying, if I expect it to be 150, what percent of the population would be larger than 156.25, given this sample standard deviation of 6.75? So since I'm trying to find the area above 156.25, that's a norm CDF. And with norm CDF, we have a lower bound and an upper bound. So lower bound is 156.25. Upward bound is going to be positive infinity. And then in the calculator, we just write that as 1E99. Then I comma the expected value, which is the mean, comma the standard deviation. And when I type that in the calculator spits back out 0.177. Which is kind of like 18%. So according to what they expect, 18% of the time, 16 people are going to get on and they're going to exceed this weight limit. So anyways, so that's how that one works. Okay. What else would you, oh, just in case you don't know, when I go share screen, if I can't see what you're typing, so the only way I can know what you're actually asking something is if I come back here to this little black screen. But if you turn your mic on, then you can talk as I show my screen. But anyway, it's not required. So anything else you want to look at? Oh, yeah, that happens sometimes. Different. Okay, yeah, go back, and I mean, I said I'd be here from 9 to 10. So if you want to take a couple minutes and look, I will play on my phone. Oh, Gene just showed up. What is that? I'm sorry, Joshua. So if you have a right, okay. Anyways, so Josh, if you come up with a question, you can type it in. Or hi, Gene. Gene, you can type a question, or if you want to unmute yourself, you can chat at me, or we can just do this. Let's let Mr. Soleil do all the talking, because that's always fun. Maybe Gene's trying to figure out how to work and get things working. Maybe. Anyways, so yeah, you guys can go look for questions, and then I'll just kind of hang out here and stare at the screen. 15 sounds great. Let me do the screen share thing. Let's get Twilight Zone weird. Dun, dun, dun. Oh, Gene, I don't know if you can hear me or not. I put a link to this answer key on the announcement part of Blackboard. So if you, oops, wrong button. If you want to go there and pull up this link, you're more than welcome to scroll around and see all the, I mean, you have all the answers because you stayed late on Monday, but if you feel like you want to do that, that would be fine. All right, and okay, so number 15, in a population of students, what is the number of calculators owned is a random variable. What is the expected value? Okay, so for something like this, we want to go to our calculator, and I luckily have one that I can play show and tell with. Okay, so from here, I want to go to Stat Edit, and let me get rid of my other stuff. Hopefully this doesn't go glitchy on me. Okay, so what I want to do is I want to type in list 1, I want to do 0, 1, 2, and 3. And then list 2, I want to type in the frequency, so the 0.2, the 0.6, the 0.15, and the 0.05. Okay, and then in order to find the expected value, that's the mean of this distribution, then I just want to go and do 1var stat. So go over to calc, 1var stat, and I have to tell the calculator that I want you to look at list 1 and list 2, otherwise it won't do it. So as long as I have that typed in there, then I can hit calculate and it will tell me what the mean is. The other way to do something like this, we don't do it a lot in class, but since you all are here, there's a VARS button, and if you scroll down to choice 5, there's actually a statistics menu, and from here we can actually ask for certain variables. I'm curious if it's programmed to do that. Okay, so once I've done 1var stats, then I can ask the calculator to give me the mean, and it will also spit it out right there. And then part B is asking what's the probability that a student will own between 2 and 3 calculators. So I just take the probability of 2, add that to the probability of 3, and that tells me total, 20% or 0.2. So, anywho, that's how you do number 15. Okay, any other requests? Sorry, I started talking with that realizing I muted my mic. Yeah, we can look at 16. All right, Twilight Zone screen share. So weird that it does that. Okay. All right, come on, you. All right, so let me take a picture of this so I can make it bigger. Oh, don't do this to me. Let me try that again. Oh, why are you being so peaky? All right. Well, it's the third time's the charm. I knew it's taking the picture. Edit, copy. No, it's just being picky. Okay. All All right, one more try, and if this doesn't work, just for some reason doesn't want to take this image and copy it and paste it. There we go. Okay, so number 16 is confidence interval on variance, which is the last new thing that we covered Wednesday of last week. So I'm going to go, apparently I'm going to click a random button. I'm going to go back to Blackboard, and I'm going to go pull down the formula chart. This is a good one to kind of emphasize the formula chart on. Okay, so on the formula chart, let's see, where are you? Confidence. Where are you? Oh, there it is. Okay, so we're looking at this piece right here to find. Oh, see now. Oh, there it is. Okay, so we're doing this formula right here on number 16. Okay, so I need n minus 1, which is the degrees of freedom. So if n in this case is 20, then 20 minus 1 is 19. Then I also need the standard deviation squared. Let's see, so I need the variance. Oh, wow. Just realized I completely set this up wrong in class. Well, we're going to do it correctly now. So that we have the variance is 11.5, and then I need the chi from the chart. So that's, see, 90% confidence, 19 degrees of freedom. So let me go to the chart here. Let me go to the chi-square page. That's table 4. Okay, so table 4, if it's 90% confidence, that means I'm looking at the middle 90. That means I've got 10% between the two tails, so each tail's got 5%. So I really want to look at the chi for 0.95 and the chi for 0.05. So I'm going to go down to 19. I'm going to come over here to the 10.117 and go over to the 0.05 and get 30.114. And that's what I want to set up. So let me get a formula type thing that I can actually put some numbers in. Okay, so we want 19 times 11.5, and then we want one of those two numbers that I just said. Of course, I don't remember what I just said, so let me come back. 10.117. And that's going to be one end of our interval. And then I want the other end to be 19.115. And do that. I think that was 30. Let's see. 30.144. Okay. So let me go back to here. All right, so I want to type that in the calculator. So 19 times 11.5 divided by 10.117, and I get 21.59. And then do the other one, which is 19 times 11.5, and then divide that by 30.144. So that's 7.25. Okay, so our confidence level would be 7. Oh, come on, quit doing that. So it's between 7.25 and 21.59 for the variance. And then if I wanted to convert that to standard deviation, I guess I should write this up here. So this is for variance, which is what the question asked. But since you guys are here, I'm going to tell you that the one tomorrow is going to ask about standard deviation. So for standard deviation, we just take the square root of that. So I come back up and take the square root of 21.59. And the square root of 7.25. So 2.69 and 4.64. Anyways, so just be aware. So what did I do in class? Oh, I multiplied it by the z-score instead of by the degrees of freedom. And nobody corrected me that I made up some fake formula. Okay, well, hopefully people will watch this. All right. She left and then she came back. Oh my. Okay. Anything else you want to look at? Okay, Gene, you can actually turn your mic on if you've got a working one. You don't have to. Josh says his isn't working, but if you got a mic that works, it gets complicated when there's like 4 or 5 of us trying to talk. You do have a mic that works, Josh.
Can you hear me?
You probably just need to turn the volume up because when you're talking and you're hijacking the screen, so it is doing something.
Hello?
It's probably muted. I don't know.
Is mine working?
I can see Gene. You can hear Gene?
Can anyone hear Gene?
Oh. How about now?
Can anyone hear Gene?
Yeah, I can hear you now.
Okay.
Can you hear me?
Yeah, I can hear you now. I have a story about why I'm an idiot. My son plays on this computer and he turns the volume down so no one can hear it. And then I don't remember to check whenever I'm on the computer. So, hey, we can talk! Yay! Alright, what do you want to talk about?
I have one, but Gene, you go ahead since I've been doing a bunch of them.
Well, thanks. On number 7,
Okay.
are you supposed to? Are you just asking for the sentence?
Good question. Okay. I am going to mute everybody. It's going to sound like I'm being a jerk, but if I go to screen share and everyone's talking, then no one gets to see what I'm showing on my screen. And then you guys can unmute yourselves here in a moment. Okay, so number 7, going all the way back up here. Okay, so the number 7 isn't actually asking about means. Let's see. So let me make it nice and big so that we all can see. And Gene, you can unmute yourself so you can actually ask clarifying questions. But so in number 7, you're given a mean of 35.67 and a standard deviation, and you're asked to compare a single person fare to the average of 8 people. So in either case, you're doing a norm CDF, and you just, with the 8 people, you have to adjust the standard deviation to divide by the square root of 8. That pretty much is it. So I don't know if you had any more questions about that one, Gene, or...
It was just the wording of the question. It was just saying which fare, if it's the fare of 8 random buses or the single random bus fare. So I didn't know you wanted the whole norm CDF, or if you just wanted why it would be more, because the single bus fare would always be greater, right? Without even having to go through all of the norm CDF, without going through the calculations.
Well, the only time, okay, so in this case, the 8 people has a higher likelihood because it's between 30 and 40. So you're within the same standard deviation around the mean. If I asked like 40 and 45, the single person would have a higher probability.
Okay.
So you do want to go through the norm CDF for both of them anyways, unless you happen to know why 30 and 40 will always generate the 8 people being a higher probability. I mean, the logic is, if I give what I like to call the freaky fare, if I ask you what's harder to get a freaky fare with, it's harder for 8 people to get an unusual fare than it is for 1 person. So, you know, if I just switch this question to go, hey, between 40 and 45, the 1 person is going to win every time. But
okay,
yeah, I would just go ahead and do norm CDF and actually get the 2 probabilities, and then you can add a couple sentences about, well, not a couple sentences, you just add a sentence about, well, as you can see, we're right around the mean, and 8 people would be right around the mean, whereas 1 person would have a harder time doing that.
okay,
Okay?
yes.
Alright, I'm going to go back to the main screen. Alright, anything else?
Can we re-go over number 11?
11? Sure. Alright, let me make it bigger. Okay, so Gallup poll conducts a national survey. 25% of all households experience some sort of crime. In a random sample of 300 households, 68 report that they've experienced some sort of crime. Construct a 95% confidence interval of the true proportion. Okay, so they actually came out and told us this is a proportion confidence interval that we are creating here. So that's just a matter of going to the calculator and pulling up, I think it's under test, and we're looking for a interval that describes this. So Z and T are both means. We don't know about 2 sample yet. We do know about 1 prop Z. So if we're doing a proportion interview, that's the one we want. And then when I hit enter, it's going to ask me for the number of successes, is what this is called. So that would be 68. It's going to ask me for the sample size, which is 300, I believe. Yeah, right there, 300. It's going to ask me for the confidence level, which is 0.95. And then I will calculate. And so the calculator will do the math for me. And it tells me that the confidence level is between 17.9 and, I'm sorry, 0.179 and 0.274. So for that first part, that's just a calculator skill, just knowing how to find that number. The second question is asking, is there evidence to suggest that the households who experience crime is less than the national proportion? Okay, so what you're looking for is the national expectation still a possibility in this interval? So so looking at your two numbers, is 0.25 still inside from the upper lower? Yeah. So as far as we can tell then, that this particular place, this Plano, Texas, isn't different than the national average. And we're not saying that they're the same, we just don't have any evidence that it's different. Does that work?
Really serious.
Yeah, I got you.
Okay.
In the test, is it going to be like specific, stating that it's a proportion, or no?
Right now we're only aware of either means or proportions, and so we only, like, let me go back to the calculator menu here. We're only aware of 3 choices right now. We're aware of a Z interval, a T interval, and a 1 prop Z. That's it as far as interval goes. The 4th test, we're going to learn a whole bunch of these things, and then it gets fun. But for right now, it's just those 3 choices. And I can't promise it's going to say the word proportion exactly, but you're looking for percent of, fraction of, out of so many. You're looking for anything that we can rewrite as a fraction or decimal or percent, and that's how we know it's proportion. If it's something like a whole number or 3.2 or something that we can't convert into a percent, then we want to look at the Z or T interval. My question back at you, Josh, is do you know how to tell the difference between a Z or T?
No.
Okay. Somewhere in the problem, let me see if I can find an example of this. Okay, so like number 12 here, they actually told us the population standard deviation. So because they told us that, this is a Z interval. Whereas number 13, they gave us a bunch of numbers. They didn't give us anything about the population. So this would be a T interval.
Okay.
So the only thing you have to go on is, do you know the population standard deviation or not? If you do, it's a Z. If you don't, it's a T.
Okay.
Okay?
Yep.
Alright, go back. See what's going on. Alright, anything else I can do?
Yeah,
Probably
on number 13, can you show us your graph for it,
Okay.
please?
Oh, no problem.
The box plot.
Oh, that didn't. Oh, there we go. I'm like, come on, you. Alright, 13. That's, when I typed those numbers in, that's about what I got.
What was that?
This box, oh, let me make it bigger.
Okay. On the calculator, can you just go through those steps one more time for me, please? Because mine just keeps saying invalid, and I don't know if I'm pressing something wrong or if I don't know, or if it's a calculator.
Okay. Yep. I'm gonna be lazy and not do them all, but yeah, I'll do a couple.
Okay.
Yeah, I mean, I just won't type all the numbers in. It's a pain in the butt with this hand. I'm using a mouse.
Okay.
So I'm not telling you no. I'm just saying, yeah, we'll do a couple here. So 224.120, and it's not the most exciting to watch me type a bunch of numbers in. I need at least about 6 or 7, otherwise the calculator will freak out on me. Alright, almost done showing you how to type buttons. Very thrilling.
Well, every little bit helps.
Alright, I get one more in. So this obviously will not be the picture that I have on the screen, but it'll be the right. So once you've got all the numbers typed into list 1, then to get it to do a box plot, you go up to stat plot, and like mine are right now, my plot 1 is turned off, so I'm going to turn it on, and you want to watch that none of your other plots are turned on. So if you got anything else that's turned on, just turn it off. So I want to turn plot 1 on, and I want it to do a scatter plot, or not a scatter plot, I'm sorry, I want to do a box plot. So we want this first option, and it's just going to ask me where are the numbers, and I'm going to tell it it's in list 1. And then from here, I'm going to hit zoom 9. Maybe I'll hit zoom 9. I didn't like that.
Can you hear me?
Yeah.
On mine, where it says frequency, it says Y.
Make it say 1.
I pressed 1, but it's still not doing anything.
Hit enter after you hit 1. Oh, wow, mine just hit Y. Okay. Check you don't have the alpha key locked. Like there's a green, like mine has a green button that says alpha.
Yeah.
Just hit it again and just try typing 1 over it.
Okay.
Alright, and then I'm going to hit zoom 9. And ta-da! It's going to make a nice pretty box plot.
Okay. Then I guess that's what I did wrong.
Yeah, it's...
Now I got a box plot.
Okay, yeah, and then... So, and whatever the thing is, whatever picture you get, just say it's approximately normal. Our class is an intro-level statistics course. I am not trying to confuse you by having you draw some weird picture, and the correct answer is, it's not normal, I can't do anything. Like, that's not what I want. I want you to sketch it, say it's approximately normal, and move on.
Okay, so yours looks different on the calculator, specifically because you didn't include all the numbers, right?
Correct.
Okay,
Yeah,
and so if you were to include all the numbers, would it show the outliers, or do we have to solve for those?
No, let me go back to stat plot. If you look under stat plot, those choices, there's actually 2 box plot options. The first box plot will graphically indicate an outlier, which we like. The second one won't. Don't ask me why there's 2 options. I have no idea who goes, I don't want to know if there's an outlier, I just want a box plot. That's dumb. But anyway, so if you go with the first option, if there's an outlier, it will always show it to you.
Okay.
Okay?
And one other question, if no one else has one.
Go ahead. Just you 2.
On the sampling distribution, that sample size has to be 30, greater than 30?
For number 13?
Well, for number 12.
Okay.
Because I'm confused between 1 being 30 and 1 being greater than 10 and 1 being greater than 30.
Okay. So, and that's good stuff to get confused. I mean, it's nice. I prefer if we weren't confused, but okay. So if you're dealing with sample mean, and I ask you, is the distribution normal? That's where you want to kick in the sample size greater than 30 rule.
Okay.
Okay. So either greater than 30, or you show me some box plot that looks approximately symmetrical. So like number 12, they told us there were 34 of them. So the sample size bigger than 30 would kick in, and I could say, oh, it's normal because of sample size being bigger than 30. However, in number 13, they didn't give me 30 numbers. They gave me less than that. So in order to say that it's normal, I have to show a box plot that indicates that the data is approximately normal.
Okay.
Okay.
So in number 12, if it would have said like 24 plots, we would have needed to have done a box plot.
Well, we don't have enough information in number 12 to actually do a box plot. But yeah, in theory, if I'd only given you 24 numbers, And to be perfectly honest, it's whatever I give you, you're going to say normal. Your job is to decide whether is it normal because the sample size is bigger than 30, is it normal because of a box plot, or is it normal because of the NP, NQ bigger than or equal to 10?
Mm-hmm.
All right. So when does that NP, NQ bigger than 10 come into play?
Proportions.
Okay.
So like number 10 and number 11 would both be proportional data. And I think number 9 is also proportional. Yeah, so 9, 10, 11 are all proportional. So those, if I ask you on anything about 9, 10, and 11, how do you know it's normal, then you would want to do the NP, NQ and show that it's bigger than 10.
Okay.
So like if you look at number 10, I asked you to give me the mean and standard deviation, and then in part B, I said, does it, is it normal? And the answer is no, but I didn't ask you to do anything with normal. I just asked you, is it normal? So that's an okay question. Like, that's fair game for me to ask. But like if number 9, where we did the norm CDF, if we checked sample size and it wasn't normal, then norm CDF wouldn't be appropriate. So we couldn't really answer number 9 if NP and Q weren't bigger than 10.
Okay. So I guess that's why you said check the assumptions so we can make sure that it's bigger than 10.
Right.
Okay.
Right. And that is something I'm looking for in the answer. So if I put something like number 9 on the test, I'm going to look. One part of the answer is going to be, did they at least check the assumptions?
Okay.
And the biggest mistake I see students do is they're like, oh, it's bigger than 30. Like, that's nice. That's not appropriate for this data. Like 160 is bigger than 30, but that's not what I need to check for something like this. For something like this, I would have to check the NP, NQ.
Okay.
So, just there to mess with you.
Thanks.
Oh, no problem. Anytime I can help. All right, you guys got one last one. I oddly enough, I actually scheduled these meetings back to back, so I have another one at 10 that I have to do with another group of students. But any last second questions I can field?
Can we print through a finished review for the test?
You can study off of this. I mean, are you asking, can I print it and use it on the test?
Yeah.
No. But I did give you a chart you can fill out, and you can put in examples. So if you want to take the time to put a good example, like the one on the review sheet, you're more than welcome to do that. But I'm at least going to make you work to have it.
Can we use the margins?
Because
I write sort of, I try to squeeze it in, but I'm having a hard time seeing what I'm writing.
That's what we got the back of the paper too.
Oh, okay, well then I'll use the back.
I mean, I don't think it's fair if a student can just print it out and that's what they're going to use to study. I think you should at least do something on your part, not figure it out the first time when you see it on the actual test. But that's just me. I'm just a big meanie, so.
Only slightly.
Yeah. All right. Anyways, I don't know if you guys are happy about this. I'm gonna make a YouTube link. I think I did it right this time, and I'll send out our lovely chat, and everyone can watch the lovely Joy.
And you had said the one you did wrong that we didn't catch was number 15.
It was the confidence interval of dispersion. So that was number 16.
Okay.
So and what we did wrong is nobody. I didn't look up the formula. Nobody looked up the formula. So I made up a new formula that I shouldn't have done.
All right.
So it's my fault. We'll say that.
Well, we'll go back and I'll check it.
Yeah, I mean, it's not. When I pull up the formula chart, I'm like, oh wow, I made up a new formula. Wow, that's terrible. Anyways, and I'll send a warning out that, hey, look over the video for 16 because the answer key is wrong.
Okay.
Okay. All right. Well, y'all have way too much fun. Don't stress too much.
I'll try not to.
All right. All right, I'll see you guys tomorrow morning-ish.
All
Okay.
right.
Later.
See ya.